Now we'll see some example problems from IUPAC names and drawing of structures of carboxylic acids. The first question is, give the IUPAC name for each compound. Now we have this first compound. Now the first step is to determine what is the longest carbon chain. This is the longest carbon chain, and next you need to number the carbon atoms starting with the carboxyl carbon 1, 2, 3 and 4. Now you can start with the alkane name. So that is the easiest, so you will not miss anything. So the alkane with 4 carbon atoms is named as butane, right? Butane. So to name the carboxylic acid, we will replace this E with oic acid. And remember, there should be a space in between the first name and the acid. Butanoic acid. Now, that's not the end. It contains a methyl group in the third carbon. So that is the substituent. So we will put that substituent name as 3-methyl butanoic acid. So that's the correct name, 3-methyl butanoic acid. The next one is a benzoic acid with the bromine atom attached as a substituent. Now we'll number the ring starting from the carbon atom that is connected to the carboxyl carbon. This is 2 and 3. So the bromine group is in the third carbon atom, so we can say 3-bromo benzoic acid. And C. So it's a line angle structure. So the most important part is to visualize the carbon atoms. Okay, if you are still confused, best thing would be to put these carbon atoms in your drawings, so you will not get confused. And there is a carbon here too. Okay, so this is a methyl group. Now, as always, you need to start with the longest carbon chain, including the carboxylic group, and then number the carbon chain starting with carboxyl carbon. There are 6 carbons in the main chain. So we'll start with the alkane name hexane. That's how we name a 6 carbon containing an alkane. So since this is a carboxylic acid, we'll replace this E with oic space acid. Okay, hexanoic acid. Now to include the methyl substituent, so this is a methyl group. Okay, the line represent a methyl group, and that methyl group is in the third carbon, so it's 3-methyl hexanoic acid. That's the IUPAC name. Now draw the line angle formula for 4-chlorohexanoic acid. Now we need to work backward. Starting from the name, we need to draw the structure. Now always it's easier to start with the terminal end of the name, hexanoic acid. So before drawing the hexanoic acid, I will just draw it's a line angle formula. I'll just draw a line angle formula for hexane. 1, 2, 3, 4, 5, 6. So this is hexane line angle formula. I'll convert this hexane now into hexanoic acid. Okay, so this is the last carbon atom, or a carbon atom in the terminal. Just pick one of them. You can pick this one or this one. Okay, I'll pick this one, and you just have to draw the carbonyl group here just by putting 2 lines to a double bond CO and attach OH group to here. Okay, So that is the hexanoic acid. Now, in the name, there's another part called 4-chloro. Okay, so I will just number this carbon chain before adding the substituent. So I know this is the 4th carbon atom. Now we'll just attach a chlorine atom to the 4th carbon atom. That's 4-chlorohexanoic acid. Okay. Now the question is, draw the structures for the carboxylic acid formed by oxidation of following compounds. So in my lecture, I explained how these carboxylic acids are prepared or formed from primary alcohols and aldehydes. So this is an example. Now, what you need to exactly look at. So just check if you see a CH2OH group. The CH2OH has to be converted to COOH. So this is the key. Okay. So whatever the group that is present here will be the same. Okay. Now look at this part A. Now where is the CH2OH? I see OH here. So this is the CH2, right? So we need to convert this part into this carboxylic acid. So I'm going to draw the line angle structure with how many carbons are there? 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. And this carbon will be the carboxyl carbon. Okay. And after you draw, double check whether you have the same number of carbon atoms as in the alcohol. So this has 6 carbons. Remember, all these corners and edges contains a carbon atom. So there are 6 here, and 1, 2, 3, 4, 5, 6. 6 here. That's how you can make sure your structure is correct. Now we have an aldehyde. So this is an aldehyde. So the same thing. Now if you see an aldehyde, so whatever the group present, it doesn't matter, it will be the same, and the aldehyde group will convert to a carboxyl group. Okay, so we'll find where is this aldehyde group. So that is in here. Okay, that's the only part which is going to change. The rest of the molecule would be the same. Like here, 1, 2, 3, 4. There are 4 carbon atoms. Now I'm going to draw that part just like that. 1, 2, 3, and 4. Okay, and the next one will be the carbonyl carbon and attach the hydroxyl group, that is the carboxylic acid. So those are the products, oxidation products for this aldehyde and the alcohol. Again, you can make sure you have drawn the same number of carbon atoms. Here in the aldehyde we have 1, 2, 3, 4, 5 carbons, and here 1, 2, 3, 4, 5. Yeah, that's how we can make sure. Okay, so these are some example problems that you can find in the homework related to the carboxylic acids, the first part of the lecture. You can practice more in your homework questions. Thank you.